Hello viewers, today we are going to be talking about electromagnetic field properties. Electromagnetic field properties due to properties electromagnetic field as properties any substance and material, of course. Electromagnetic field is impacting on the charge which in the magnetic field replaced by this formula describing electromagnetic force equals charge which in the magnetic field is multiplying round brackets. In the round brackets we have electric field plus they are vector values, electric field plus in the square brackets we are expressing vector multiplying velocity of magnetic field changing by electromagnetic field, close square bracket, close round bracket. Electromagnetic field either has energy, electromagnetic energy, has an energy, electromagnetic, which expressed this formula, electromagnetic energy equals electric field by permittivity divided by 2 plus permeability by magnetic field. Sorry, it's wrong. Erase this. Divided by 2 divided by permeability of magnetic field. Permittivity is epsilon sub index 0 equals 4 pi by 10 power 10 round brackets power minus 1 volts divided by meter. Permeability is mu sub index 0 equals 4 pi by 10 minus 7 power. So they are basic formulas of electromagnetic field. Electromagnetic field has such any substance mass, has a mass expressed this formula m electromagnetic subindex is a subindex equals electromagnetic energy divided by light speed by power 2, and electromagnetic field has another property. Its property is quantity of movement expressed letter P electromagnetic electromagnetic sorry electromagnetic equals mass by light speed. Mass by light speed. Next electromagnetic field is exist such as direct current or direct field or alternating current field. Direct current field we can considering as separately from electromagnetic field, and electromagnetic field as electric field and magnetic field separately. Next, if electromagnetic field as alternating field, we cannot write doing such earlier. We are considering electromagnetic field as electric field and magnetic field, not separately. We don't separate electric and magnetic field in this case as alternating. Next we will be considering electromagnetic field as relations between electromagnetic waves, relations as differential relations and integration relations. Differentiational relations expressed as curl from divergency as first. Curl we will be considering as second part of considering of directions electromagnetic field. Divergency expressed by Gauss formula this formula is integral by closed surface S square surface, electric or any vector value. Let be electric field as vector value d s vector equals integral by volume divergency electric field d volume is equals full charge a rounded surface. The surface in the rounded surface is charge. Maybe it plus charge, positive charge. from the charge is arrows. These arrows are expressing directions of electric field from the charge. Full charge F, let be F, Q, F, divide permittivity 0 by permittivity relation. Relation permittivity is permittivity of any substance. For any substance we have own, for each any substance we have any permittivity. Further, if we divide this formula from volume, dividing this formula by volume, this volume we will get next: divergence. We get divergence of electric field equals density, in this case, of field divided by epsilon 0 epsilon r. We got this from Q F divided volume, it equals density of charge, of full charge. Next we have Coulomb's law. Coulomb's law sounded as F equals Q1 by Q first by Q second divided by distance between charges, letter R designated power 2, multiplied by unit vector R. R is a unit vector, is vector value, of course. Next formula is potential of electric field. Potential of electric field is equal charge divided by distance for point in which we are measuring electric field. And electric field self equals charge 1, charge first, divided by R power 2, R unit vector, multiplying by R unit vector. And next formula which we will be considering is formula of energy of an electric field. An electric field energy expressed this formula. Energy electric equals integral Q. Q is a charge multiplied by integral from point 1 to point second, from point first to point second, integral from electric field d differential multiplied on differential r, differential of distance. It is an energy is integral electric field by distance multiplied by charge. And next we have potential 1 point minus potential first point minus potential in second point equals integral from first to second point electric field by differential of the distance between first and second point. This is a difference between potentials in 1 point and 2 point, first point and second point. Another formula for electric field is write it as electric field equals as vector well equals as minus gradient phi, or equals nabla operator phi minus, of course, equals minus this operator nabla we can write as d phi dx by unit vector e as unit vector plus in the round brackets d phi dy g unit vector by g unit vector plus d phi dz by k unit vector is a gradient of potential. A gradient of potential is an electric field expressed. And the next formula is this formula is this an Gauss theorem about electric charge which rounded a closed surface around the charge. Next we have next formula. As formula Stokes, formula from Stokes' formula is the formula is integral at closed loop L. In this case, so what we considering? We considering magnetic field. Next, magnetic field d L. L is a contour that close looped. We can take it unit of contour as vector, a long contour. It equals integral by surface which limited by this or constrained by this contour. What we can image this such contour L, and S is square rounded this contour. Equals curl H ds. S is a vector while 2 can S is a normal vector to this square rounded this contour, which rounded this contour. Next, curl ds hs. This all equals full current. Current is exist from 3 parts as value to as values which we are considering, which we was considering earlier. Density of current equals current divided by surface. Density full equals density of conductivity plus density of replacement plus density of P. P is produce density. We are calling it, if we can. Density of carrier, density of conductivity, we will express it by this formula. This formula is derivative of displacement of electric field divided by time, derivative by time. It all equals as d epsilon 0 d e by dt plus dp by dt. P is a polarization, E is a epsilon is a permittivity, as we know earlier. Next formula is for density of replacement. Is density of replacement current. This subindex R. Next formula is formula for conductivity current. Rho equals this letter, Greek letter gamma, by E. E is electric field of inside electric field that inside electric field. Electric field can I cannot I didn't mention about electric field divided or exist. Electric field exists from two parts: electric field inside and electric field outside. Electric field inside is electric field insert. Electric field outside is electric field inducted by insided forces as chemic impacts or electromagnetic inductions forces or impacts, if you can. Next formulas. As we guess, the formula is formula Maxwell's formula. We have got formulas Maxwell as formula Gauss first formula, formula for current, almost full. For current, further we are getting further further. For current is curl of magnetic field. If we dividing this formula by square, we will get this gamma is conductivity, electric field plus derivative of displacement, electric displacement by time, by divide time by time. It is a differential formula of magnetic field. Differential formula for magnetic field. This is integrational formula. Integrational and differentiational formula for magnetic field. This is a differentiational formula, Gauss law. This is an integrational formula for Gauss theorem. Underscore this, we are underscoring this Gauss formula for electric field formula. For electric field and for magnetic field. For magnetic field next formula, Maxwell's, is integral on surface square on square of full square of full surface B equals 0 or divergence of H equals 0 or divergence of B equals permeability 0 multiply H plus J. J is magnetic value which depended from substance which we are considering in this moment for this station of field. Next formula and last formula for this our lesson is formula for electromagnetic and induction. If we are painting contour close looped, and through closed loop we have conducting magnetic field B, or if we B multiply for square of which rounded this closed contour, we will get magnetic flux. We will get. If we doing such, we paint this contour, magnetic field, we get ADS or current which will flow this through this contour, or we get the electromovement force EMF EMF which targeting against right direction, which clockwise if we use rule which we look this on this picture. Therefore we get formula as theorem of Stokes. Next, integral around contour electric field dl vector values. This is scalar multiplying of vectors equals minus df divided by dt. This is derivative. This is the derivative of time, derivative by time. Next, if we divide by s by square, we get formula about Stokes theorem, curl E vector E equals minus D magnetic field by time. Also, we have got Maxwell formulas as integrating formulas for electromagnetic field and differentiating formula for electromagnetic field. This formula we are write as integral by S electric field ds equals charge full, 0 permittivity. Integral, round integral L H dl magnetic field by L by contour equals full current. Integral B by S ds equals 0 integral L E dl equals minus d phi divided by dt. This is integrational. Next, differentiational. Integrational, differentiational. Okay, so wrong, right? Sorry. My bad pronunciation. Integration and differentiation. Next, curl H equals gamma E plus d divided by dt curl E here B here, curl E equals minus d B divided by dt. Divergence of B equals 0, and Gauss theorem, divergence of E equals density divided by epsilon 0 epsilon r. Our lesson is end. Goodbye.